In the Solve It, you thought about the relationships that must exist in order for a bulletin board to hang straight. You will explore these relationships in this lesson. In the diagram below, line CD is the perpendicular bisector of segment AB. Line CD is perpendicular to segment AB at its midpoint. We should note segment CA and segment CB are drawn to complete triangle CAD and triangle CBD. You should recognize from your work in Chapter 4 that triangle CAD is congruent to triangle CBD. So you can conclude that segment CA is congruent to segment CB, or that CA, the distance, equals CB. A point is equidistant from two objects if it is the same distance from the objects. So, point C is equidistant from points A and B. This suggests a proof of Theorem 5-2, the perpendicular bisector theorem. Its converse is also true and is stated as Theorem 5-3. Theorem 5-2, the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So, if line PM is perpendicular to segment AB and MA equals MB, then PA equals PB. And Theorem 5-3, the converse of the perpendicular bisector theorem. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if PA equals PB, then line PM is perpendicular to segment AB and MA equals MB. Problem 1, using the perpendicular bisector theorem. And this one's related to algebra. What is the length of segment AB? Well, consider the diagram carefully. Segment BD is the perpendicular bisector of segment AC. So B is equidistant from A and C. We can state BA equals BC by the perpendicular bisector theorem. So 4x equals 6x minus 10 using substitution. Negative 2x equals negative 10 as we subtract 6x from each side. And finally, x equals 5, dividing each side by negative 2. Now we need to find AB. Well, AB equals 4x. We know that x equals 5, so substituting 5 for x, we find that AB equals 20. Your turn. What is the length of segment QR?